So now we're going to talk about chapter 12, which is linear regression and correlation. So a lot of times professionals want to know about how two variables are related to each other. So for example, is there a relationship between the grade on the second math exam a student takes and the grade on the final exam? What kind of relationship, if there is one, and would it be strong? So think about it. If you were going to do well on the second exam, that would probably show that you're going to do well on the final exam, but we can't make that assumption. So another example is your income could be determined by your education, your profession, your years of experience, and your ability. You can actually build a model to see where people's incomes are broken down by education, profession, years of experience, and ability. The amount you pay for a repair person for labor is often determined by an initial amount plus an hourly fee. So if you hired a plumber and they charge $65 to come out and then it's $120 every hour, that's basically a regression. You're comparing two variables, time and experience and cost. So a type of data described in the examples is a bivariate data. Bi means two variables. In reality, statisticians use multivariate data, meaning many variables. In this chapter, we're only going to learn about linear regression, which is for every x, there's a y. Just know that you can do huge types of regression models called linear, where you add more variables than two, and logistic, where you even put in categorical variables. So for us, all we're going to do is a very simple form of linear regression. So linear regression for two variables is based on a linear equation with one independent variable. You might remember this. This is the formula for a line. So the equation for linear equations is y equals a plus bx, where a and b are constant numbers, x is the independent variable, and y is the dependent variable. Typically, you'll choose a value to substitute for the independent variable and then solve for the dependent variable. The graph of a linear equation form of y equals a plus bx is a straight line. So any line that is not vertical can be described by this equation. Okay, so go back to algebra and remember when you had to determine the slope and the y-intercept for a line. You've seen this equation before, you've used it before, but you haven't used it in terms of linear equations like this. So let's think about it. Aaron's WordPress service does word processing. The rate of services is $30 per hour plus $31.50 one-time charge. The total cost to a customer depends on the number of hours it takes to complete the job. Find the equation that expresses the total cost in terms of the numbers of hours required to complete the job. Let X be the number of hours it takes to get a job done, and let Y be the total cost to a customer. Okay, so let's break this down. The $31.50 is a one-time charge. Regardless of what you're getting done, you get that charge added to you. Then the $32 is for each hour after that. So we can write this as a linear equation. We can do y equals that fixed cost of 31.50 plus 32 times x, where x is the number of hours to get a job done. So for the linear equation y equals a plus bx, b is the slope and a is the y-intercept. You will also see this reversed. In the calculator, it's done two ways. You might see it as y equals ax plus b. Just know the number right next to x is the slope, and the number by itself is the y-intercept. So from algebra, recall that the slope is a number that describes the steepness of a line, or many of you, when I say what is slope, everybody will answer rise over run. And the y-intercept is the y-coordinate of the point 0, a, where the line crosses the y-axis. So what that means there is x is 0, and your y will be determined where the line crosses. Okay, so let's look at these possible graphs for linear equations. So A is if B, which is your slope, is greater than 0. The line slopes upwards to the right. So B is where the slope equals 0, which means it's a horizontal line. There's no rise or run going up. It's just flat. And then B minus 0 or less than 0, the line slopes down to the right. You can have negative slopes. You can have positive slopes. You can have a slope of 0. This is just showing every combination you can have. So another example of linear equations, Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. The linear equation that expresses the total amount of money Svetlana earns in each session she tutors is y equals 25 plus 15x. What are the independent and dependent variables? What is the y-intercept and what is the slope? Interpret them using a sentence. So take a few minutes, pause the video, and try to work on this on your own, and we'll come back to it. Okay, so let's go over the answers. The independent variable is the number of hours Svetlana tutors each session. The dependent variable, y, is the amount of money she earns in each session. Because if you think about it this way, she can't earn money unless she has hours. So that's a way to think about it. So her tutoring results in the money. So sometimes X and Y can be kind of tricky, but C, usually one will depend on the other. So the y-intercept is 25. At the start of a tutoring session, Svetlana charges a one-time fee of $25. So this is when X is 0. Nothing's going on, just right out the bat. You sit down with her, that's $25. So then the slope is 15 because she charges $15 each additional hour.